Hey, so our first section we're going to look at this week is the second part of 2.2. We started it, I think, last academic Thursday. There's really not too much at all to cover, and then we'll be done section 2.2. All right, so what we're going to do is we're going to start out with an example that we're going to look at graphically and a little bit algebraically. And it's going to be about a company that produces a product. And the company has two different kinds of costs. They have one cost that's fixed. Okay? It doesn't change no matter how many of the product they produce. And the other cost is variable. Okay? The variable cost is going to change depending on how many of the product they produce. Okay? So this particular company makes T-shirts, and they have a fixed cost of $200,000. Okay, so that could include things like the rent they pay for the building, the salaries for the employees, whatever it is. But that costs never change. Okay, the cost that does change depends on how many shirts they make. Okay, so it costs them $1.50 per shirt they make, and they're going to sell the shirt for $4. All right, so before we go any further, I just want to make sure people understand the difference between cost, revenue, and profit. Okay, I don't have that word up here, but it's important. So the costs are what the company pays out. Okay, any money that comes out of their accounts, that's their cost. Revenue is money they take in. Okay, revenue is not necessarily profit. Okay, revenue is just how much money came into the company. And then if you do something with subtraction, you could figure out profit. Okay, if you look at how much revenue they made, take away the costs, that's the profit. Okay, any questions on that? All right. So what I want to do is come up with an algebraic representation for the cost. Okay, come up with a formula, and then come up with a formula for the revenue. All right, what do you think we're going to have to do here in order to come up with equations for the cost and for the revenue? We've got to do something first before we can come up with an equation, because this thing I'm thinking of is going to be part of the equation. Yep?
We need to give them variables.
Yeah, we need a variable. What's the variable going to represent in this problem about this company? Yep?
The cost to produce each shirt individually.
Well, that we know. We know the cost to produce each individual shirt is $1.50. Okay, so that's not going to be the variable, but it is something to do with the shirts.
Never mind. The shirts themselves.
What about the shirts themselves?
How many are produced?
How many? Yeah. So let's just define our variable. Okay, so let's let x equal the number of shirts produced. Or it could be sold. Okay, whichever formula we're using. Okay, so let's start with C of x. Our cost as a function of x. Okay, what's my formula for my cost going to be? Okay, and when we write the formula, you need to take into account both costs, the fixed and the variable. Any guesses, John? Any guess on that?
I would say like you'd want to have like 200,000 plus.
All right, that's a good start. So we got 200,000 plus
150. It would be like 150 divided by 4.
So for our costs, we don't really have to look at anything that has to do with what we sell the shirts for. Okay, costs are just what does it cost us to make the shirt, not necessarily what we're selling. Yeah.
Wouldn't it be 200,000 plus 150x?
Yeah, 200,000 plus $1.50x. Can you explain that?
150x, whatever you plug in for x, that's how many shirts are made. So,
And why are you multiplying it by $1.50?
because that's how much it costs to make a shirt.
Right. So we have to pay this cost for every single shirt that we make. The 200,000 you do not pay for every shirt you make. You pay that one time, and that's it. It's a fixed cost. Okay. And now let's look at our revenue. Okay. Remember, revenue is not profit. Revenue is just how much money do they make. Okay. Anyone think they can give me a formula for my revenue as a function of x? Yeah, Adrian?
4x.
Yeah, this one's just 4x. Okay, so that's all they ask us to do in this part. They don't ask us to find out anything else. Any questions on the representations of these? All right, so now let's try to make a graph. And I've got some pretty big numbers here. Okay, so I'm definitely going to have to adjust my x-min and x-max. How about Alex? What if you look at this as like the equation of a line? What's this 200,000?
Wouldn't that be the y-axis?
It's the y. What do we call that? The y what? It is where it crosses the y-axis. Yeah, the y-intercept. Okay, so my y-intercept is up at 200,000, and it's only going up. The line's going up from there with a slope of 1.5. Okay, so I've got to set my y-intercept at a minimum of 200,000, and then it's going to go up. Okay, if you're just graphing this one. Now, this other one has a y-intercept of 0. All right, so we've got quite a difference in these two graphs. So let's see what we can do. So we've got 200,000 plus 1.5x and 4x. Okay, if you just do a standard window, this is what you're going to get. Well, you might get something on the profit or on the revenue one. Okay, but we can't even see the other line because it's up at 200,000. All right, so how about x minimum? Is there a minimum number of shirts that makes sense in this problem?
0.
Yeah, I wouldn't look at negative shirts. Okay, maximum number of shirts we sell, we don't know. Let's just say 10,000 shirts. Okay, y is our cost or our revenue. Depends on which graph you're looking at. Either way, negative costs and negative revenue don't make sense. Okay? You can have negative profit, but not negative cost or revenue. All right, our y min 0. Let's set our y max at, yeah, we could go 300,000. I'm going to even go 350. And that's our costs. And there's our profit. Okay, it's a little hard to see with this window, but what's going to happen eventually?
So we'll cross each other.
Yeah, they are going to cross. Okay, it definitely doesn't happen selling 10,000 shirts. Let's try selling 100,000 shirts. Here's our cost. Here's our revenue. And they do cross. Does anybody know what would happen at that point?
I think you're making more money than you initially started with. Like the amount of money you put in to start is no longer a thing because you paid it all off.
Yeah, so we've now paid off our 200,000 fixed cost, and we've produced enough shirts that now we're starting to make money. All right. Does anybody know what you call that point? It is an intersection point, and then from a business standpoint, it has a special name. Break even, yeah. Okay, so that's the break even point. Okay, that's when your costs and your revenue come out the same. And obviously on a graph, we already answered, where is that point? It's where the two lines cross. Okay, it's where our cost function and revenue function cross. Right, so now you can probably guess what's coming next. We're going to figure out exactly how many shirts do we need to make for the company to break even. Okay, and there's a couple ways we can do it. We can do it graphically. I think most people would know how to do it, but we can go through that. But first, I'm going to do it algebraically. Right, so can somebody remind me again, what does it mean to break even? It's where what equals what again? It's where cost equals revenue. Where revenue equals cost. Same thing. So that's what I want to figure out algebraically. Where does cost equal revenue? Okay, let's go back to our formulas. And for C of x, I'll plug in 200,000 plus 1.5x. And set that equal to my revenue, which is 4x. Okay, now we just solve. Okay, Austin, what would be my first step to solve that? Because this is going to be a linear equation, no, we don't have to. We want to get the letter on one side and the number on the other. If it was a quadratic, we would.
Letter on one side.
Mm-hmm.
So you guys get x alone.
Get x alone, yep.
So divide by 4. Oh no, I don't know.
Yep, great.
Subtract 1.5.
Yeah, we're going to subtract 1.5x from both sides. Okay, so that leaves me with 200,000 on the left, 2.5x on the right. Austin, you have a chance to redeem yourself.
Now you divide.
Now we divide, not by 4 though. What do we divide by?
2.5.
Divide by 2.5. And I think that's going to be, does anyone have a calculator, 80,000? Is that what it came out to, John?
Yeah,
80,000, thank you. Okay, so that's 80,000 shirts. If they sell more than 80,000 shirts, they start making money. If they don't sell that many, then they lost money. All right, now graphically, we're pretty much already set up to do it from the first part. Okay, we've already graphed. All I have to do is see where these cross. Ethan, can you tell me the buttons I pressed to find where these two lines cross?
Second count.
Second calc.
Intersect.
Intersect. Okay, pick a point on the first curve, second curve, and are these lines ever going to cross more than once? No, so the guess doesn't really matter. It'll figure it out. Okay, and it tells us, same thing we got algebraically. 80,000 shirts. Okay, but this intersection point also tells us something else. What would be my cost to make 80,000 shirts?
80,000.
Well, we have at least a 200,000 cost, even if we don't sell any shirts. So it's got to be more than 200,000. Luke?
$320,000.
Yep. So my cost to make 80,000 shirts is $320,000. What's my revenue if I sell 80,000 shirts? Well, my profit is 0, but what's my revenue?
320,000.
My revenue is 320,000. My cost was 320,000, so was my revenue. My profit now is at 0, and now I start making money. Okay. So any questions on that? All right, so that's it for section 2.2. Okay, that's all that was left in that one. All right, so now we're going to take a look at some quadratics. You like these, Austin? Now we got to get equal 0. Okay, so linear equations we don't have to, but quadratics we do generally want to get it equal to 0, whether you're going to factor it or use quadratic formula. Either way. Okay, and we're going to focus on doing it algebraically. Okay, so the last section we did a little bit graphing. We're not going to do as much with the calculator in this section. All right, in order to have an equation, what symbol do you have to have?
Equals.
Yeah, you got to have an equal sign. Okay, it's a statement of equality. Okay? And you have to have two expressions. Okay, so you have an equal sign, you've got something on the left, something on the right, and there's an equation. Now, equations don't always have to use variables. Okay? I think I'm going to, down below, I'm going to explain this a little more, but this is an equation. That's a contradiction. It's not true, but this is an equation. It fits the definition. Okay? This is also an equation. Okay? This is an equation that doesn't use any variables, and it's called an identity. Okay? An identity is an equation that's always true. A contradiction is an equation that's never true. And I'll show you how you could end up with something like this in a second. Okay? And then another kind of equation is this. This is called a conditional equation. It could be true. Depends on if you pick the right value for x. Okay, so conditional equation, identity, contradiction. Okay, if you have an equation that has an x in it, then we say we have an equation in x. Or the way I usually say it is we have a function of x. Okay, so when we did the revenue and cost problem, I pronounced this c of x, r of x. It's a function using the letter x. Or an equation in x. A lot of times I say of, c of x. That's how I say it. Yeah, but you might see that notation in the book if they write something like that. Okay, to solve an equation, okay, means just to find the values or values of x that make it true. Okay, some equations can have more than one answer. Generally, simpler kinds of equations don't. Think of when you graph a line. Okay, if it's anything other than a horizontal line, it can only cross the x-axis once. If you had something like a parabola, that's a U-shape, okay, it could cross the x-axis up to 2 times. Okay, and generally, the higher you make the exponent, the more answers you could have. Okay, so if I were to graph something like this, this graph could have up to 3 answers. Okay, it could cross the x-axis up to 3 times. I don't guarantee it'll cross 3 times, but that's the maximum it could cross. Okay, and a part of what we do, I think it's more in chapter 3, but we learn a lot about what this exponent tells you. How many turns the graph can take, how many times it can cross the x-axis. Okay, so you don't have to worry about that yet. Okay, so earlier I described to you what an identity was. Okay, an identity is an equation that's always true. You can pick any number you want in the domain and it'll always work. Can anyone explain to me why this equation is an identity? Think about if you start to solve it. Look at what's going to happen. Denver?
It's going to equal the same as the left if you distribute.
Yeah, if you distribute on the right, you get 3x plus 3. minus 1. 3 minus 1 is 2. So you get 3x plus 2 on the left and on the right. That's an identity. Okay. Any questions on that? Okay, so you can't find a value for x here that would make it false. I don't care what you pick. Positives, negatives, fractions, decimals, 0. As long as it's in the domain, yes. And imaginaries technically are in the domain here. They would work as well. Okay, a conditional equation, I told you what that was earlier. It's an equation that could be true. Okay, it depends if you pick the right value for x. Okay, and I guess I should add in the last type, okay, a contradiction. Basically the opposite of an identity. It's never true for any values of the variable. Never true. It's never true no matter what values you use in the domain. Okay, here's an example of an equation that would be a contradiction. Let's say 2x plus 4 equals 2 times x plus 3. You will never be able to solve that equation. Okay, because if you distribute it out, you're going to get 2x on the left and on the right. So what happens is the 2x's are gone, and you're left with 4 equals 6. Okay?
Not about right.
Yeah, that's not going to work. Okay, so any questions on the 3 types of equations? Okay, so is this an equation? 2x plus 4.
Yes. No.
No, what's that?
That's a statement.
That's problem.
It's an expression. Yeah, specifically this is an algebraic expression. How about, is that an equation?
No, it's a number.
Nope, that's just a number. That's just a numeric expression. How about that? Is that an equation?
We don't know yet.
It's not an equal to expression.
Yeah, you got to have an expression on each side, whether it's numeric or algebraic.
What about?
It's nothing, yeah. So now if I put in this, is that an equation?
Yeah.
Yeah.
What kind?
Contradiction.
That's a contradiction. How about this one? Is that an equation?
Yeah.
Yeah.
What kind of equation?
The one that works.
That's
Identity.
That's what?
Identity.
That's an identity. You get the same thing on the left and on the right. Okay. Questions on what an equation is, what it isn't, and the different types. All right. Okay, so if you want to check if a number is a solution to equation, all you have to do is take what you think is the solution, plug it in, and see if you get a true statement. Okay. So this might be a little hard to solve without a calculator on our own. We don't have a formula for cubics. We don't have the cubic formula. There is a cubic formula, but we don't use it. It's very, very complex.
Resulting explosions?
I don't even know if I understand it.
No.
Oh, so,
I mean, Mr. K, you're a pretty smart
yeah, I
guy.
know. Yeah, there's a ton of variables. It's like the quadratic formula times 10. It gets really, really hard to use. And honestly, we could probably do it faster without it than with it, especially with a graphing calculator. All right. What do we want to make sure, especially if you're going to type this into the calculator, when you plug in the -2 for x, what do you want to make sure that you do with it? Yep.
Take the sign with it.
Yeah, and how do we make sure that the sign is also going to get cubed? What symbols do we use? Parentheses. Yep. So make sure when you plug in that -2 on the calculator, you do it like this. For this particular problem, if you didn't, you'd get lucky, it would work. But if you don't, especially when the exponent is even, we run into problems. So just always do it. Now, when I plug -2 in on the left, what am I hoping it simplifies to?
0.
I'm hoping I get 0. If I do, then it's a solution. Okay. -2 cubed is -8. What's minus a minus? That becomes +2 plus 6. -8 plus 2 is -6. And at this point, we can see what's -6 plus 6? 0. Okay, so we proved that -2 is a solution. Okay, does anybody remember what I said earlier about this exponent? How many solutions could there be?
3.
There could be up to 3. Okay, I'm not going to guarantee that there are 3, but there could be 1, there could be 2, there could be 3. There can't be 0. Well, first of all, we just proved that that's a solution. But even if you didn't, odds always have to have at least 1. Okay? Odd exponents. Okay, so we'll learn that later on. Okay, the way it would have 3 solutions if it did something like this. If it has an exponent of 3, it can turn twice. Okay, here's your first turn, here's your second turn. Okay, that's how you could get 3. Or it might not turn at all. It might just do this. And we just get 1 solution. Okay? To know what type it is, we'd have to graph it. Okay, so simplest kinds of equations, the one we've been working with here, these are called linear equations. And a linear equation has the form ax plus b equals 0. And the a and the b can be any real number that you want. Okay, so we're not talking about imaginaries. A and b are elements of the real numbers. There's only one thing you're not allowed to use for a, and that's 0. What would happen if you plug in 0 for a? What does that do to my equation?
Makes it b equals 0.
Yeah, what it does is it wipes out the x term, and now you just have a number equals 0. That's not a linear equation. Okay, so we can't let a be 0, but it can be anything else other than 0. Hey, and if you think of this as a linear equation, what is a? If you were to draw it, it would be my what of the line?
Slope.
It'd be my slope, and b would be
The intercept.
my y-intercept. So a lot of times you see mx plus b, ax plus b. It doesn't matter what letter you use. Right, so algebra 1 type equation, I just want to go through. This has got a little bit of everything in it, distributive, combined like terms. We want to make sure we can solve it, and then we're going to move on from linear equations into absolute value. Okay. Hannah, can you tell me the first thing I'm going to have to do on the left side? And I might have to do it twice.
You're going to distribute 2 into the entities.
Yeah. Anything else we have to distribute?
You also have to distribute the C into both entities.
Right. Okay, so for now, we're just going to keep the right side as 5x plus 2. And on the left, Nick, can you tell me what I get when I distribute?
You get 4x minus 6.
Okay, and how about Luke when I distribute in the second parentheses?
3x plus 3.
3x plus 3. Okay, so I did my distributive property. What do I do next? Yeah, combine any like terms you can on the left-hand side. There's nothing you can combine on the right. John, can you tell me 2 things I can combine and what I get when I combine them?
4x and 3x, which is 7x.
So combine the x's.
And then -6 and 3.
-6, positive 3 gives me -3. Okay. So now I don't think there's anything else we can combine. Now we're going to start shifting things from side to side. Curtis, what would I do next here?
Subtract 5x from each side.
Yeah, so there's a couple different options he could have said. I think subtracting 5x is probably one of the better ones because it's going to allow us to just deal with positive numbers. 7x minus 5x gives me 2x. Okay, how about Jack? What would be my next step?
You could add 3 both sides.
Yep. Add 3. So 2x equals 5. And how about Ethan, my last step? Yep, divide by 2. And we get an answer of 5 halves. Or you could put 2.5. Okay, so any questions on solving basic Algebra 1 type equations that have distributive, combined like terms, stuff like that? All right, next type of problem. Okay, absolute value equations. Okay, these kind of equations are still Algebra 1. Okay, so we'll go through them kind of quickly, but they're a little more involved, so I got to give you a few more steps. Okay, when you have an absolute value equation, the first thing you have to do is make sure that the absolute value is by itself on one side. Okay, let me show you an example of one that's ready to solve. Okay, the absolute value is by itself. If you have numbers on the outside like that, you have to get rid of these numbers and put them on the other side. Okay, so get this block of stuff by itself, the absolute value. Okay, after you've isolated it and you have it by itself, now we can split it into 2 problems. Okay, because generally absolute value equations have 2 answers. Okay, generally. I'll show you an example where that is not true in a second. Okay, but the first equation that you split it into, it's exactly the same as the original. Just take away the absolute value bars. Okay, so you're going to copy down exactly the problem that I give you, just take away your absolute value bars. Now for the second equation, you've got to do everything you did to get the first one, and one more thing. So copy down the original, except you get rid of the absolute value bars again. So far, the same thing. But the other thing you have to do is negate, which means change the sign of the number on the other side. Okay, that's the extra step. So your second equation, take the original, get rid of the bars, and change the sign of the number on the other side. Okay, negate is just a shorter way of me saying change the sign of. Right, so we'll take a look at that and see if we can solve it. Okay, so first thing says we have to make sure the absolute value is by itself. Okay, that's already true here. Here's an example where it's not by itself. Does anybody know what the first step would be to get this 3 on the other side?
Subtract 6.
If you had a plus in here like that, then you would subtract it. But since this is multiplication,
You want to divide it.
yeah, we want to divide by 3 and by 3. And if you do that, you get exactly the problem I have right here. Absolute value of 2x plus 3 equals 5. So Hannah, the kind that you said if you had something like this, I'm trying to make it the same as the other one. If you had that, now the first thing you would do is subtract 5. And subtract 5. And you get exactly the same problem we have. Okay, so if you kind of get confused, okay, what I do is I think of it like this. Okay, take that. It doesn't matter what's in the absolute values right now. Okay, you can't even look at what's in the absolute values. All I know is I have to get rid of everything that's next to them. Okay, so Pretend that that absolute value is just one big block, you can't even see it, and get rid of everything that's next to it. Okay? All right, so this one is ready to split because the absolute value is by itself. Can anybody tell me my first equation that I'm going to try to solve? Ian?
2x plus 3 equals 5.
2x plus 3 equals 5. And what about my second answer? Or, well, not answer yet, second equation. About Ryan?
What was the question again?
My second equation.
Yeah.
Priya?
2x plus 3 equals -5.
Yeah. So my second equation, she did it perfect. Okay, 2x plus 3 equals -5. Okay, now solve each equation. How about Connor? What's going to be my first step? And actually, it's going to be on both.
Subtract 3.
Yep, so we subtract 3. That's gone. That's gone. On the left, Connor, what do I get?
You get 2x plus 2.
Yep. And my other answer, 2x equals -8. And my last step, which I'll do on both sides. How about Brad?
Divide by 2.
Yep. Divide by 2. And Brad, what do I get for my two answers? X equals 1 and -4. Perfect. Okay. Questions on that? Okay, let's look at, I want to look at, if that was example 3, you could call this like 3A. I'll call this one 3A and this next one 3B. Same kind of question, okay, solve it, but a little different. Okay, any thoughts before we start solving this one?
Everything's one side.
Okay, so the absolute value, yeah, it's by itself. Any other thoughts?
Looks pretty standard.
Looks pretty standard.
The answer is negative.
Yeah, it can't be negative.
Okay, so yeah, if you don't notice that, then we're going to run into a problem. Okay,
Negative absolute value.
absolute value can never equal a negative number. The problem is if you try to solve this, you're not going to run into any like algebra problem or error. You're just going to go through it and think everything worked. You're going to write x plus 2 equals -1. X plus 2 equals +1. Subtract 2 from both sides. You get x equals -3. And you get x equals -1. But the problem is if you don't check your answers, you won't see they don't work. -3 plus 2 is how much? -1. And what's the absolute value of -1?
1.
+1. That doesn't work. If you plug in -1 and add 2, what do you get? 1. What's the absolute value of 1? 1. That didn't work either. So this one has no solution. So I said to you, generally absolute value equations have two answers. This is one that has none. Okay. What if I had, let's call this 3C, something like this. What would you say there?
There are negatives on both sides.
But I have a negative. I thought I said if it has a negative on the right, it's
Yeah,
no
but
solution.
If you start
If you
doing
divide the negative by the negative,
Absolute value.
Yeah. Problem here is the absolute value is not by itself. So if you divide by -2 first,
it makes it
now you've got a problem you could solve. Okay, I'll leave solving it to you. So the point is, don't just look at the right side and say, oh, it's negative, I can't solve it. Well, depends if the absolute value is by itself. Okay, so that's pretty much every little trick you have to worry about with absolute value. Okay. Questions on that one? All right. Okay, so the last kind of problem we're going to look at before we finish with quadratics, which is just using the quadratic formula, which I'll remind you if you don't know it. So the last problem type for linear equations is what's called a mixture problem. Okay, so these kind of problems, they're going to say you've got two different liquids, you're going to mix them together, and what they're going to want you to do is mix them together so you have a certain amount of stuff and a certain concentration. Okay, so maybe if you think of like in chemistry, maybe you've got a 10% solution of something and a 20% solution. I want you to mix the two together so that when you're done, you got 15 gallons of a 12.5% solution. How much of each one do I need to mix to make that happen? Okay, if you follow these two equations, it makes it a very easy word problem to do. Okay, the first equation has to do with how much of the first solution plus the second solution, add them up equals the total. Okay, they'll always tell you how much they want you to mix. Okay, and the second equation, it's the concentration of the first solution times how much you use, plus the concentration of the second times how much you use, equals the final concentration, which they'll tell you, times the total amount of liquid they want you to have, which they will tell you. Now, a shortcut is we can kind of do substitution in our head, and then you don't need two equations. But we're going to hold off. I don't think I want to do any part of this in my head. Okay, I'm going to write all the steps down. All right, so in our example, we're going to mix two solutions. One of them is a 10% solution. One of them is a 25% solution. Okay, the only thing I need to know is how much do they want me to create? How much stuff do they want me to make? And how strong? What percent do they want? Does anyone have the two equations? Okay. So they want me to mix it so I have 15 liters of a 12% solution. How much of each solution do I need? Okay, so it might seem kind of complicated, but really once we set up the equation, you'll see this is going to be a very basic equation to solve. Okay. Before I can even set up an equation, okay, just like I did in the t-shirt company problem, what do I need to do first? And in fact, this time I need to do it for two things.
Set variables.
Yeah, I need variables just to represent the amount I'm going to use for the first solution and the second. Okay, doesn't matter what two letters you use. I would say since I call them solutions A and B, why don't we just use A and B? Right. Can anyone give me one of my equations? Let's start with the top one because that's a little simpler. So what are you thinking for an equation, Luke?
10% plus 25% equals total amount.
So is 10%, is that an amount? Or is that a concentration?
No, typically it's a concentration, right?
That's a concentration. So we want amounts. Those are, A is how much I'm going to use for solution A, and B is how much I'm going to use for solution B. So any revised thoughts?
So we know it has to equal 15 liters, right?
Yeah. And what are the two things we're going to add together to get 15 liters?
12% of the solutions, right? I don't know.
Anyone help him out? So he got the 15.
You got it.
Let me put the equal sign in there.
A plus B.
What is it?
A plus B equals 15 liters.
Yeah, A is the amount of the first solution, B is the amount of the second. However much you mix, there's your equation. Okay, now we need the concentration one. Anytime you use a percent, okay, in a formula in math, what do you usually have to do to that percent? You got to make it a decimal. Okay, so what's the concentration of my first solution as a decimal? 0.1. Okay, so I just filled that in. 0.1 times how much am I using for of the first solution? We don't know, but how did we represent it? A. Plus, I need my concentration of the second solution. 0.25 times how much of the second solution am I going to use? B. Equals. This is my final concentration. When I mix this all together, what do they want the concentration to be? 12%, which is 0.12 times my total. Final amount of liquid here is 15. Okay, second equation I can simplify a little bit. We don't really need the parentheses. I can multiply 0.12 times 15 and just get a number. Okay, so 1.8. Okay, so I'm going to use this equation. And I need to use the top equation somehow. How can I do something to the top equation and then use it in the one I just put a box around? Any thoughts, Brett?
Solve for the letter in the top equation and then plug that into one of the letters in the bottom.
Yes. Get one of the letters by itself here, and it doesn't matter. So which one do you want to do? A. Can you tell me what, if I got A by itself, what A would equal?
15 minus B.
15 minus B. Okay, if the L is confusing, I'll just put 15. But it's 15 liters. And what letter are you going to plug that in for, Brad?
You're going to plug that into A.
Yep. I'm going to fill that in right there. And when I fill it in, what symbol do I want to make sure I use? Yep, because we're going to have a distributive property. So we're going to put 0.1 times A. But now for A, I'm going to fill in 15 minus B. Plus 0.25B equals 1.8. Now that we did that, how many different letters do I have in that last equation? Just one. I no longer have an equation with two letters. Now I have one letter. And as soon as I solve this, I will know B. Okay, so I'm going to do 0.1 times 15, gives me 1.5, minus 0.1 times B, plus 0.25B equals 1.8. Okay, combine your like terms. We have negative 0.1 plus 0.25. Okay, what's that going to be?
Negative 1.15.
Negative or positive?
Oh, positive.
Positive. Yep. Think of it's like 25 take away 10. You want to think of it with integers. Okay, so 0.15 equals 1.8. 2 steps left. What's my second to last step? James?
Subtract 1.5.
Yep. Subtract 1.5. Okay, that's going to give me 0.15b equals, what's that, 0.3? And my last step, divide by 0.15. Okay, and this is the same as asking how many times does 15 go into 30?
Twice.
Goes in twice. 0.15 goes into 0.3 twice. So I'm going to go back up. I know B is 2 liters. So how much is A?
13.
Yeah, it's going to add up to 15. So that comes out to 13. Okay, so any question on that one? Okay, you'll probably see one mixture problem on the test. I think there's one. All right, so anybody needs a copy of that?
Yeah.
Yep. All right, so last thing we'll do, just going to remind you of what the quadratic formula is and how we use that to solve an equation. Okay, so in general, quadratic equations have this form: ax squared plus bx plus c. And a, b, and c can be any number you want, except don't make a 0. Because if you do, if you make that a 0, you just wipe out the first term, and now you have what we've been talking about, just a line. Okay, one way to solve a quadratic equation is to factor. Okay, some people don't like the factoring because you kind of have to guess a little bit at how to do it. But the first thing that always has to happen is it has to equal 0. Okay, we talked about that earlier. And then you've got to find two numbers that multiply to give you your first term. How about my signs here? Both positive, both negative, or one of each? Well, if they're both negative, then we do a negative times a negative. That wouldn't give me a negative for my last term. Denver?
Positive and negative.
Yep, and it does matter which one we put where. Just a hint, I'll try it that way. And two numbers that multiply to give me 3. Okay, luckily, there's only two numbers you can multiply to get 3 that are nice numbers. 3 and 1. And if you check that, that works perfect. Now, once you factor it, what do you do with each one of these factors? Yeah, you set them to 0. Okay, so with a quadratic, you usually get 2 answers. And what's my other one? Negative 3. Yeah. Okay, so factoring is usually pretty fast as long as it works, and the numbers are reasonable. Okay, if you have numbers that are huge, factoring is not the best method. So what can we do besides factor? Yeah, you can always use your quadratic formula. Okay, so quadratic formula always works. It's not the fastest way, especially if you can factor. Okay, so your quadratic formula, make it a little bigger if you can't see it. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and if you're wondering, well, what is a, b, and c? They're right there. So notice again, what does the equation have to be equal to? It's got to be equal to 0. If it's not, do that first. Okay, so let's go through this one. We'll identify what A, B, and C are first, and then we'll plug them into the formula. Okay, Jacob, can you tell me in example 6, what is A?
2.
2? Yep. Fred, how about B? 2? And what about C? If we get confused, I'm gonna do something to show you, but I want to make sure people get this right.
Is it -1?
Yeah. Okay, notice this one's not the way they asked you to set it up. Okay, so the first thing you really want to do is this. If you can see what A, B, and C are without doing that, that's okay. Okay, now let's fill it all into the quadratic formula. Austin, can you fill that in for me, into my quadratic formula? That's good. All right, so he started us off, -2 plus or minus the square root. Luke, can you finish that part?
2x minus 1.
So quadratic formula,
Oh, is it quadratic formula? That means b squared
okay.
minus 4, and then AC to be 2 and 1.
Careful,
-1.
-1. All over
2, 4.
2 times 2, which is 4. Okay, so Luke told me I'm going to subtract, and that's a minus. Okay, so when you subtract a negative, it becomes a positive. 4 times 2 gives me plus 4? 12. And how does the square root of 12 simplify?
3.46.
As an exact. We can reduce it, though.
It's like 2 square roots of what or something?
Yeah.
You gotta do that?
Yep.
Yeah, I have no idea.
What two numbers can you multiply to get 12? And one of them you can take the square root of nicely.
4 and 3.
So you break it up like this.
2 and 6.
Oh, really?
Yep. And now, which one of those can I take the square root of?
4.
That's how you simplify the square root of 12.
So much easier.
You can make a tree. There's different ways to do it, sure. And now, anything I can reduce in my final answer? Or reduce by? Yeah, I can reduce by 2, 2, and 2. So my final answer, -1, plus or minus square root 3 over 2. Now, when you solve a word problem, make sure that negative answers make sense. Okay? Maybe if you're talking about length, you'd only want the positive, but depends on the problem. Bless you. Okay, so any questions on quadratic formula?
You
Yep.
go up, please.
Yep.
Yay!
Yay. All right, so yeah, homework tonight. Okay, on page 89. 35 to 39, I think that's just one question about break-even point. It's like the first one we did. And page 96, that's on the linear and quadratic equations. 1 through 4, 9, 11, 13, 19, 25, 26, 37, and 38, 52 to 54, and 58. Okay, I think 58 is a word problem, so if you get stuck on the word problem, don't worry too much. We'll go over that one in class.